Hi, I'm Zlatan Cinic. I'm a Senior Solution Architect for Amazon Web Services. In this video, I'm going to show you how to build a .NET chatbot using Amazon Lex, AWS Lambda, and Amazon Cognito Identity. Let's get started. So the .NET Core chatbot application code allows you to actually order flowers using chatbot powered by Amazon Lex, which is our Alexa service, or rather service consumed by Alexa, AWS Lambda, Amazon Cognito Identity, and above all, the full CI pipeline that supports the actual development and release and deployment into build and QA production or dev environment, right? So we're going to go and we're going to get an overview of these developer tools like AWS Code Pipeline, Code Build, and Code Deploy. So what is Lambda? Lambda is basically a serverless function application. Literally just means that you have to worry about the code that you're writing in, and you can hook into any type of event source. That can be a change in a data state, it can be a request to an endpoint, or it can be a change in a resource state of any sort. We do support different types of languages besides obviously .NET, C#. We also support Node.js, Python, Java, and Go. And of course, now Lambda can go ahead and talk to whatever it wants, however it wants after that. And you don't have to worry about where it gets deployed, how it gets deployed. Rather, you don't have to worry about availability for it, durability. Everything is, and that's really what serverless implies, is that you don't have to worry about any infrastructure or server aspect of deploying your code, just what is written in your code. So looking at the common use cases, we have web applications, backends, much like what we're going to see now, both the web application and backend, data processing, chatbots, this very example, as well as use with Amazon Alexa, Alexa skills, and then various IT automation. So I have built various automation aspects using Lambda because you can really easily hook into any infrastructure event, any ops event, and any security event as well. And then you can actually automate actions which can either fix or prevent or intelligently act upon those events to actually proactively do some sort of ops or administrative maintenance. Amazon Lex, this is the actual core service that Alexa uses. So what does it have? It has, and it's really part of our machine learning offering of already pre-learned models that are ready for you to consume. So it offers dialogue management, speech to intent, text to speech, analytics, obviously security for all that, business logic, scale, and you have a luxury of one-click deployment, completely end-to-end, right? So what is Lex commonly used for? Well, much like Alexa, it's a bot, right? So it's so many different bot use cases here. We have contact center bots, informational bots, application bots, enterprise productivity bots, Internet of Things bots, right? All these cool things that you can build and use. Amazon Cognito. Got a lot of questions from a lot of developers. Hey, what can we use for identity management for our applications? So since identity is central to your application ecosystem, especially when it comes to .NET and Microsoft world, right? This is one of the most important aspects. So whether the user is a consumer, a partner, or an employee through the multi-channel app ecosystem, they need to have an identity that can be verified as well as provide the right permissions and right access for these users. So looking at, from an overview perspective, you can actually you can use the federated identity and federation pools as well as identity pools. So you can create identities and manage users in Cognito itself through manage user directory, You can use it as as part of the hosted UI, or you can federate to other web applications as well as common cloud services like Google, Amazon, Facebook, any SAML-aware service itself. So. And of course, you can federate to your AWS credentials, and it supports both the OAuth as well as the SAML tokens, like I said earlier. So, what are the custom user flows using actual Lambda hooks? You can have custom authentication flow, which actually where you define an authentication challenge and create that challenge or verify it. And then you can actually hook into various different events, like pre-authentication, post-authentication, pre-token generation, and you can then hook into events around the sign-up as well, pre-sign-up, post-confirmation, migration, whether you're migrating users and you want to retain existing passwords, and so on and so forth. And of course, messages, custom messages that you can send out, advanced customizations and localization for these specific messages. This is a demo that I've developed with developer evangelists, great people, as well as our product team members. Very proud of this. So if you go to aws.amazon.com/net/buildabot, you will see this, and I will take you through it right now. So as you can see, when you go to the URL, you're going to be presented with this pretty cool page with all these crazy bots on top. And also an explanation exactly to what you're going to get here and what you're going to do. It shows here that time to complete is 1.5 hours. Since this is supposed to be a very short video, we're going to cut this down. But I want to kind of go through, the main aspects of how to build the bot here. So let's go to number 1, to create a bot. And you can see here it actually gives you a complete step-by-step instruction on how to build and deploy a bot specifically. So if we actually go to our Lex service, so Amazon X, here I am in my console. I can say I want to get started. And as you can see, there are several samples. We're going to be using this order flowers one. And you can see that it already pre-created a role for itself. And this is pretty important, especially if you actually want to use it outside. You need to indicate if your use of this bot is subject to Children's Online Privacy Protection Act. So I'm just going to say no, otherwise it's not enabled, because this is just for a demo that is going to be destroyed very shortly. So as you can see, the Order Flowers bot has been built. And then let's actually take a look at all the different aspects of the bot. Over here, you can see sample utterances like I would like to order some flowers, I would like to pick up flowers. And of course, you can extend that. You can actually add it and add as many as you want to in the whole thing. Then you can also create slots for it, such as different flower types, as well as the pickup date and pickup time. And those are the slots, the queues that effectively the bot is going to be using. You can, as you kind of create this, and on a fulfillment side, you can actually say, hey, once you actually get the order, go ahead and initiate a Lambda function or return parameters to a client. You also have a confirmation prompt. So this is an example, but you can obviously edit this. It says, okay, your flowers have been ready, will be ready for pickup at this time and this date. Does it sound okay? And then it actually asks for yes or no, and then on the no, it actually gives you a prompt. And you can kind of extend that prompt based on, keywords that you want to include over here. And what's really cool about this is that you can then go ahead and test this bot out, and you say, I would like to order flowers, and it says what type of, you see, even here it says, it says I would like to order some flowers. It's smart enough if I don't have to say exactly that. I can just say any variations of that, and it's going to know that I want to order flowers. And it says what type of flowers. I'm going to say roses. It says, what day would you do you want the roses to be picked up? Now, obviously, I can give it a date, but I can say things like tomorrow. And it's smart enough to figure out what tomorrow is, right? And it's going to ask me, well, pick up roses at what time tomorrow? So I'll say 10 a.m. It says, yes, you can pick it up at 10 a.m. Does this sound okay? I'll say yes. Boom. Here's our instant order fulfillment is going to actually initiate a Lambda. And then we can go ahead and hit publish on this guy. So going back over here, that would mean our bot is ready to be consumed. Next bit is actually to go ahead and create a Lambda function. As you can see, you have different ways of creating a Lambda function. You can do it via Visual Studio. You can do it through .NET CLI Core. You can create Lambda function using the AWS Management Console and or using the actual CLI. So we can go ahead, and this is the difference. As you can see, yeah, we had CLI, but if we had .NET Core CLI, and this is actual AWS CLI, right? So we're covering all bases over here. And the next bit would be obviously testing that Lambda function and making sure that it actually works properly. And the last bit is then configuring the Lex bot to be used in this particular case. So let's go over and just see how we would actually go ahead and create this Lambda function. So here I am in my favorite workspace environment. This is once again Amazon Workspaces, where I can run any Windows environment that I want to. I can run full Windows 10 as well if I want to. So here's my Visual Studio opened up with my Visual Studio toolkit for AWS with my profile selected and my region. So I'm going to go ahead and click on File, and I'm going to say, hey, new project. And in new project, I'm going to select Lambda project for .NET Core. And over here, I'm going to say, hey, it's order flowers function. And I'm going to go ahead and create it. And as you can see, it has a whole bunch of different blueprints, once again, and which is going to help us in this particular case because we actually have a blueprint for Order Flowers Chatbot. So it will make it a lot easier for you. So we're going to pre-select this guy, and then we're going to say, hey, go ahead and create this for us. So it's going to actually not only create the full project and solution, but also use sample code for us that we can actually adjust to the bot that we just created and make sure we reference the bot and the rest of the solution. So as you can see, as part of the solution, we have our NuGet dependencies, and then we have abstract intent processor. We have the flower order function, as well as the function over here class on what the response is going to be, intent processor, and then order flowers intent processor that comes through it. So you can see here that we actually have all the code that we need to build out whatever logic that we want and integrate into whatever we would like to integrate into. This is a ready-made project. This is ready to actually go ahead, right-click over here and say we want to deploy it. See, published to AWS Lambda. Don't forget when you do so, because this is still 1.0, right? We want to make sure that we are pointing to the right assembly. So in this case, we're going to select the right framework. So when that actually is done, we're going to go ahead and rebuild this solution, make sure it's building, and it is. And that's great. 0 errors, 0 warnings, and then we can go ahead and publish this Lambda directly. And as you can see, our language runtime has been selected. We can then create, we can say order flowers function. You can say next. You can create a new role or existing role. We're going to use a new role based on AWS Lambda full access policy. And you can see we can do various things, such as we can define how much memory and timeout we want to give this Lambda, as well as now we have support for dead letter queues as well. We can create environment variables that Lambda can consume, and then we can also use a KMS key to encrypt it. But in this case, we're going to go ahead and upload this guy, and that will conclude our creation of the Lambda and deployment into AWS as part of the solution for the order flowers function. So now that we've completed the create Lambda and deployment of the Lambda, next bit is to actually set up Cognito. This is an instruction on how to go ahead and create a Cognito federated identity pool, and then how to actually go ahead and configure the pool for the app itself. Once you do that, that's going to take you about 10 minutes, and it's fairly straightforward. So over here, you're going to have instructions on how to clone a GitHub repo, configure IDE, basically it's just a button for the most part, but it will actually give you instructions for both Mac, Windows, and Linux. Change settings that are necessary. But over here, I already have actually all the code that I've created as part of the .NET Lex chatbot. It's in my repository in GitHub called Dare to Code, called Chatbot Test specifically. So I'm going to go ahead and proceed over here to a deploy bit, and in deploy bit, you're going to have you're going to see here different different aspects like Linux server deploy, as well as Windows server deploy. And so here, in order to speed up the deployment, we can actually use CloudFormation template, which is going to create a full code pipeline with code deploy and code build. So we're going to go ahead and click on the CloudFormation template here. And this is actually go ahead and it's going to download a YAML template for us. So back over here, we're going to go and click on CloudFormation as a service, and here we go. It just came up as the first bit here. We're gonna go ahead and click Create Stack, and then in Create Stack, we are going to actually go ahead and upload the template that we just downloaded. This is the chatbot template. Then we're going to go ahead and click Next. And in there, you're going to see that the stack has a whole bunch of properties. We can give it a name, Chatbot Lex Sample. Sample as in project ID. And these are the things, project ID and app name is what code deploy and code build needs specifically. This is specifically for code deploy, in fact. Since we're going to point it to my actual repository over here, we're going to say the GitHub owner is Dare to Code. OAuth token I actually saved over here. So I'm going to go switch over to provide an OAuth token, and the repo is Chatbot Test. So let me just make sure I don't make a typo over here. We're going to use a Chatbot Test repo. I'm going to say instance type is T2 micro, that's fine. It's a very light application. Key pair name, I'm going to select my test key pair name. We're going to deploy this guy on Ubuntu, and we can actually go ahead and select VPC where we want to have this deployed. So here we are. We're going to click Next, and we're going to skip this one. And then we're going to say we acknowledge that AWS CloudFormation might create resources for us. This is specifically when it comes to naming them. And then we are going to go through the events. We're going to wait until this full dev environment has been created. So as you can see now, we have the whole environment created over here, and it actually takes you step by step, on what it created and how. It's kind of smart enough on what it needs to create first, second, and what its dependencies are. So we're going to go ahead and go to see what it created, and it should have created a full CDCI pipeline using code pipeline. So we're going to go and select code pipeline. Here it is. And on the code pipeline, you can see our Chatbot sample pipeline that was created a minute ago. And you can see right now that it's actually not only that it successfully pulled all the code from my GitHub repository, but it's actually right now building and it's about to deploy. So if you go over here, the code build, the next two steps, the code build and code deploy, are fairly easy to actually configure, and they're configured mostly by means of app spec and build spec files. So if you look at the code build, in this case uses a build spec file, you can define phases, and then you can say in these phases like pre-build, build, and so on, you can actually write down the actual bash commands that you want to code build to execute. And in this case, what it's doing is that it's deploying .NET, installing it, and then it's publishing the actual .NET project that we have in there, and it can run tests, it can do a whole bunch of things. So it's not just building like what it's doing in this case, and it's creating artifacts, and here you're defining which files you want and how you want them included, but also it can actually execute tests. And separately, in the app spec file, it's very similar, very much the same. It's makes a reference to the files that you have and says where you want to copy them, what the source and destination is. And then again, on the hooks, it says on application stop, before install, after install, and application start, execute these specific basically commands. These are the scripts that contain commands. So what I've done is that I've put all these scripts, or rather commands, in specific scripts, and they're in the scripts folder. And I just told it execute this script, this script, this script. And if you look at what that looks like, here's my scripts folder. And here's install.NET Core, for example. And here it shows you all the commands that are put in to install .NET Code. Same goes for installing HTTPD, and this is installing Apache. Same goes for starting a service. As you can see, I put a whole bunch of, so it actually makes it a lot cleaner and a lot easier. And most importantly, as you can see, it's still deploying. It's very simple and very familiar for both developers as well as administrators and ops people that might be also part of this CI/CD pipeline itself. So right now the code deploy is actually deploying, and as you can see now the application has been deployed. You can literally click through any of these steps. You can actually add additional steps. You can edit this entire pipeline, and they can be parallel steps or sequential steps that you want to add. But we can click through the service, in this case, code deploy, and you can actually see where the revision location is, and you can even deploy earlier revisions. We're going to click on this particular deployment. You can see it succeeded. If it did not succeed, we actually have access to all the logs and all the things. It also tells us where it deployed to the specific instance. So if we click on the instance itself, as you can see, the instance is up and running. It's great. We can actually use this public IP to take a look at what has been deployed. And as you can see, here's our bot that we just created, and we can say, hey, I want to order flowers. And this is what type of flowers. Again, roses. This is what day do you want roses to be picked up. Just like I said before, I want it tomorrow. And I will say 12 p.m. And I will say yes. Yep, and my roses have been ordered. So I just showed you how to build a .NET chatbot with Amazon Lex, AWS Lambda, and Amazon Cognito Identity. I hope you can take advantage of it. Thank you for watching.